Lightning is a powerful and potentially dangerous natural phenomenon, but it is important to understand its properties and behavior based on scientific evidence, rather than misconceptions. Lightning is a sudden electrostatic discharge that occurs most often during thunderstorms. This discharge happens between electrically charged regions within clouds, between clouds, or between a cloud and the ground. The charged regions in the atmosphere that cause lightning are created by complex processes that are not completely understood, but they generally involve ice crystals, supercooled water droplets, and propel interacting within strong updrafts and downdrafts inside a storm cloud. As these particles collide, electrons are transferred, leading to a separation of charge, with typically a positive charge accumulating in the upper regions of the cloud and a negative charge accumulating in the lower regions. When the electrical potential difference between these charged regions or between a charged region and the ground becomes sufficiently large, it exceeds the insulating capacity of the air, resulting in a rapid discharge of electricity that we see as lightning. Lightning strikes can be cloud to ground, cloud to cloud, or intra-cloud. Cloud-to-ground lightning poses the greatest risk to life and property. The typical process of a cloud-to-ground lightning strike begins with a step leader, which is a channel of negative charge that propagates downwards from the cloud in a series of discrete steps. This step leader is invisible to the naked eye. As the step leader approaches the ground, it induces a positive charge on objects below, such as trees, buildings, and even people. When the step leader gets close enough, typically within a few tens of meters, one or more upward streamers of positive charge reach up to meet it. Once a streamer connects with the step leader, a highly conductive channel is formed, and a return stroke occurs. This return stroke is the bright flash of lightning that we see. It travels upwards from the ground to the cloud at speeds approaching 1/3 the speed of light, carrying a massive electrical current. The intense heat generated by the return stroke rapidly heats the air in the channel to temperatures as high as 50,000 degrees Fahrenheit, which is about 5 times hotter than the surface of the sun. This rapid heating causes the air to expand explosively, creating a shock wave that we hear as thunder. Because light travels much faster than sound, we see the lightning flash before we hear the thunder. The distance to the lightning can be estimated by counting the seconds between the flash and the thunder and dividing by 5 to get the distance in miles, or dividing by 3 to get the distance in kilometers. Lightning can cause significant damage due to its high current and intense heat. When lightning strikes a building, the current can travel through the electrical wiring, plumbing, and structural components, causing fires, explosions, and structural damage. Electronic devices are particularly vulnerable to lightning strikes, as even a nearby strike can induce surges of electricity that can fry sensitive circuits. To protect buildings and electronic equipment from lightning strikes, lightning rods and surge protectors can be installed. Lightning rods provide a preferred path for the lightning current to flow to ground, diverting it away from the building's structure. Surge protectors can block or divert surges of electricity that can damage electronic devices. There are several misconceptions about lightning that are important to dispel. Firstly, lightning can strike the same place twice. In fact, tall, isolated objects, such as trees and skyscrapers, are more likely to be struck by lightning repeatedly. Secondly, rubber tires do not protect you from lightning in a car. The metal frame of the car provides some protection by acting as a Faraday cage, which conducts the electricity around the occupants and into the ground. However, convertibles or cars with fiberglass bodies do not offer the same level of protection. Thirdly, it is not safe to be indoors during a thunderstorm. While being inside provides some protection, it is important to avoid contact with anything that conducts electricity, such as phones, computers, and plumbing. Finally, lightning does not only strike during the peak of a thunderstorm. Lightning can strike before the rain starts or after it has stopped, so it is important to take precautions even if the weather seems to be improving. To stay safe during a thunderstorm, the following precautions should be taken. Firstly, seek shelter inside a building or a hard-top vehicle. Secondly, stay away from windows and doors. Thirdly, avoid contact with anything that conducts electricity, such as phones, computers, and plumbing. Fourthly, wait at least 30 minutes after the last thunder before going outside. Lightning is a fascinating and powerful natural phenomenon that can be both beautiful and dangerous. By understanding the science behind lightning and taking appropriate precautions, we can reduce the risk of being struck and stay safe during thunderstorms. Lightning protection systems are designed to minimize the risk of damage from lightning strikes. These systems typically include lightning rods, surge protectors, and grounding conductors. Lightning rods are installed on the highest points of a building to intercept lightning strikes and provide a path for the current to flow to ground. Surge protectors are installed on electrical panels and outlets to protect electronic equipment from voltage surges caused by lightning. Grounding conductors provide a low-resistance path for the lightning current to flow to ground, minimizing the risk of damage to the building and its contents. The effectiveness of a lightning protection system depends on its proper design and installation. It is important to consult with a qualified lightning protection specialist to ensure that the system meets the specific needs of the building and complies with relevant safety standards, such as those established by the National Fire Protection Association in NFPA 780. In addition to lightning protection systems, there are other measures that can be taken to reduce the risk of damage from lightning strikes. These include unplugging electronic equipment during thunderstorms, installing lightning arresters on antennas and satellite dishes, and trimming trees that are close to buildings. It is also important to be aware of the weather conditions and to take precautions when thunderstorms are forecast. This may involve postponing outdoor activities, seeking shelter indoors, and monitoring weather alerts. Understanding the behavior of lightning is crucial for ensuring safety and minimizing the risk of damage. While lightning can strike anywhere, there are certain factors that increase the likelihood of a strike. These include the height and isolation of an object, its proximity to conductive materials, and the local topography. Tall, isolated objects, such as trees and buildings, are more likely to be struck by lightning because they provide a shorter path for the lightning to reach the ground. Objects that are close to conductive materials, such as metal fences or power lines, are also more likely to be struck by lightning because these materials provide a path for the current to flow. The local topography can also influence the likelihood of lightning strikes. Areas with high elevations or steep slopes are more likely to experience lightning strikes than flat areas. This is because the electric field is stronger in these areas. The intensity of a lightning strike can vary depending on several factors, including the amount of charge in the cloud, the distance to the ground, and the conductivity of the air. A typical lightning strike can carry a current of 30,000 amps or more and can generate a voltage of millions of volts. The energy released by a lightning strike can be immense, and it can cause significant damage to anything in its path. Lightning is a natural phenomenon that is not capable of emotions or opinions. It is important to rely on scientific evidence and understanding to make informed decisions about safety and protection during thunderstorms.